So last time we did stacks and queues. Today we're going to extend the queue class from last time. I think the stack, you could write stacks more and more, but I think we're going to have plenty of, how should I put this? Practice using recursion, which uses the stack later on, so I don't think we need to do that. But we will do a queue because a queue is actually very important. So going back to our queue class, I think this is basically the same as what it was last class. Wait, was the last lab just stack or was it stack and queue?
Stack and queue.
Yeah, that's what I thought. So now we're going to add two more functions. The first one is add with priority. I didn't talk about this too much because we were doing some examples. But with add with priority, you're going to add a value to the queue with respect to priority. So unfortunately with this one, it might be a little harder to use the STL list. You're going to, you may end up wanting to use a vector because then at least you can move it down and then call insert and put it within a spot. For this to function, lower number is a higher priority. So if the queue is 5, 10, 15, I add 7, it should become 5, 7, 10, 15. Okay? All right, the next one is, we're doing shortest path. Okay, we didn't talk about this too much. We didn't talk about how to get the number, unfortunately, but I will show you how to do that momentarily. Actually, let me show you that right now because we're almost done. That is not what I meant to type. So if we wanted to find the shortest path, num steps to visit point, let's go ahead and actually let's just call it int steps because I don't want to make this too complicated. All right, so when we begin, number of steps is 0, and each time we add a point, we're going to add p.steps plus 1 because we're taking a step. And then when we return p.steps. And then down here, we're going to return -1, and now it's an int. And let's see if that test actually starts working for us. Nope. Because now it's different, so we need to go back and update our test. Ooh, that's equals true. That's not what we want. We're going to be, well, the number of steps does not equal -1. We're going to have to stick with that for now because that's all we have time. Wow. Actually, it does equal -1 because we failed. All right, let's see if we pass now. Oh, we missed which one? Which one do we miss? 84, so right here. So it's saying it found one? Oh, we're not putting it in our print statements. So I kind of went on autopilot. Sorry about that. What am I doing here is every time you add a point, we record the number of steps that you've taken so far, so we can keep track of the number of steps you've taken. So point 0 is, when you're at the beginning, you've taken no steps, and then each time you move on, you take 1 step. And that way, you can find out once you've found the end point, you can simply return the number of steps you've taken. All right, except for some reason, I have must have mistyped something. We're trying to go here, and was there a full wall here? So it was passing before. Needs to be -1. So test 4, we put out the print, so we got to see what's going on here. Great. Test 4. I don't see it doing that. Looks like it checks all of them and doesn't find anything. Where's it trying to go? To 4.4. Right, so here it never found it. Notice up here it found 2.0, and that's why it ended. But here it's, and then it's saying array should be equal to -1. Am I not returning -1? It does say -1, right? Come on, guys, what am I missing? Returning failure, and then it doesn't pass. All right. Am I looking at the correct test case? 4455. Okay. I feel like I'm in the Twilight Zone all of a sudden. I've got to be missing something. It's got to be obvious because I'm returning a failure, which should be returning -1, but equals negative. All right, well, let's do this. What is it returning? Interesting. Okay. That is an integer. Right. Oh. Yep. Because the compiler linked it as a character because it was a Boolean, but it linked it as an unsigned Boolean, which is why 0 minus 1 was 255, because if it's an unsigned character, 0 minus 1 is 255, and that's why you got that number. Okay, great. Well, we solved that riddle. Okay. So return the length of the shortest path, but with warps. Now, one other thing I wanted to mention is, since we're here with a number of steps, why is breadth first, once it gets to the spot, going to return the number of steps? In other words, couldn't we have done this with depth first search? Right? We could do depth first. It would go all the way here. And actually, if I remove this, it would have gone all the way around up here and found it. But would that have been the shortest path? No. So we would have had to try every single spot. But with breadth first, once we find it, find the spot, it is the shortest path. Everyone see that? That's very important. So there's the, whew, that was cute. All right, so the map is a 2D array, just like we've been working with. Width of each cell having the following properties. 0 is open, -1 is a wall. We did that a little differently. And greater than 1 is a warp. A warp is a value greater than 212, and warps to the position first 3 digits, second 3 digits. Hence, 1000 warps to, okay, this is a little confusing. It's greater than 999, but 100 or 100,000 warps to 10, and 9023.109 warps to 203.109. In other words, to get the value, this is the code you need. To get x, take whatever the cell value is, divide it by 1000. To get y, take the integer value, mod it by 1000. And now you have your x and y. The warp is where you can jump to or warp to. So there may be a shorter path if you use the warp, or there may be no path using a warp. And of course, there may be multiple warps. Does this make some sense? I'm sure y'all played games where you jump in a portal and all of a sudden you're over there, right? It's the same idea. So here you need to give me the shortest link.
There's a lot more fun there.
What's that?
Except there's a lot more fun there.
What are you talking about? I know this can seem a little daunting at first, but get used to this algorithm, these two algorithms, depth first and breadth first, because they are very common solutions to numerous coding problems, especially in games, but also in graph theory as well as other domains. So it's important to get used to these two algorithms. We're going to do breadth first search because I've learned that that's the one students have more trouble with for some reason. Don't know why, but whatever. So we're going to do that one, but now you're going to basically take my code, make it match the specification, add warps, and don't forget to do priority. Any questions?
What do you mean by when you say a warp is a value greater than?
Ignore that part.
Okay.
That is wrong, and I'm going to update that right after class. That is not correct. Ignore that. But it's going to be greater than 999. I just added 3 extra digits for some reason.
It's due a week from today.
Yes, isn't that what it says?
I don't think it did, from what I remember.
Uh-oh, that would be cute. February, whatever. It's due a week from today. It's due in the past. Huh.
So first we gotta make a time machine.
Well, we're doing warps, right?
Yeah.
So now it's time for the time warp.
Sounds awesome.
We've got this. All right. Any other questions, comments, screams, groans?
Just internal screening.
Just internal screaming.
See, now it's close to big right
Do you have
now.
a
Tired screen.
it's a tire scream? Hopefully you have a better idea of the stacks versus queues today, and that's the point. All right. That is all for today. Have a good weekend. I will see you on Monday, because fall break is a week from Monday. Is that right?
Yeah.
Excellent. Week from Monday.
Something like that.
Oh, that means your midterm's right after fall break. Oh.